Hello students, Ms. Slyman here with your 3.5 notes on polynomial graphs. So we've seen a few graphs of polynomials, and you already know some graphs of polynomials. So we've seen lines and quadratics, which are both polynomials, and both of those have certain features that are true on all polynomials. So polynomials are continuous. We can draw them without ever lifting our pen or pencil off of the paper. Polynomials do not have holes or breaks or asymptotes in their curve. They're smooth and no corners or cusps. So this graph is a piecewise graph. It has two separate parts. This graph we've seen a lot. That's a rational graph. It's asymptotic. The absolute value graph has a corner. And this cusp here is formed by the positive and negative side of a radical graph. So we don't have any of these sort of sharp points that happen at corners and cusps in polynomial graphs. Also, polynomial graphs have specific shapes. So like I've said, we've seen lines and we've seen quadratics, and that generally defines our behavior with polynomials. So if we have an odd degree polynomial, so odd, the numbers 1, 3, so this is like x to the first, x cubed, x to the fifth, etc. If the leading coefficient a, well, we already know if that's positive, we have a positive slope in a line. Also, we have the same sort of end behavior that we go from down to up. And this is like a line with a positive slope. So this is if a is positive. So for any odd, the ends point in opposite directions. If a is negative, well, if that was a line, it's a negative slope. And then we have things like a negative x to the fifth graph. So we go from up to down. When we have even degrees, those look like x squared. So those look like quadratics. So if a is positive, we start and end pointing up. So here, it's like a quadratic. And there might be lots of bumps in the middle. That changes as our power changes. If it's negative, well, negative x to the squared points down. And the same thing for any even power. So this would be, with all these bumps, that would be like an x to the sixth. And it would be a negative x to the sixth because it points down. So we can think about even having the same thing happen as a quadratic, that we have both ends point the same direction, either both up or both down. If it's an odd power, it's like a line. We point in opposite directions, up to down if it's negative, down to up if it's positive. In the next video, we're going to look at actually making some of these graphs.